Okay, in the last lesson we were working on solving quadratic equations, and we used a process of factoring to find the zeros of the quadratic equation. In this particular lesson we're going to use the roots, or the square root, to find the solutions to the quadratic equation. And if you can remember, we have a standard form of a quadratic. And if you recall that 2 represents the degree value, right? It represents the degree. So that's the degree of that polynomial function, which makes it a quadratic. So that tells us the type. But it also tells us, if you remember, a few things. It tells us the solutions, it tells us the zeros on the graph, which are the x-intercepts, and it also tells us the roots. So for the most part, those things are synonymous. Now we're going to hit some little nuances here where you can see that the zeros and the roots are a little bit different. And if you recall from solving quadratics using factoring, we used a process called the zero product property to help us find the zeros of the function. Now what you're going to find is whenever you get quadratics, you're not always going to get a quadratic equation that is factorable, and so we're going to have to look for other methods to do that. So we're going to be looking to use square roots, and this is where simplifying radicals is going to be an important process. Now I'm going to just kind of go back and discuss a few things about square roots. If you remember, whenever we had this radical sign, we had this understood root of 2 in there, and so you can recall that 2 would offset the square, and so leaving you a positive 2. Now, if you remember, 2 squared is not the only value that can actually end up equaling the 4. So this could also be written as a negative 2 squared, and of course that would give us a positive 2 and a negative 2. Now, since we have 2 separate roots for 4, we have the positive version and negative version. What we can basically do is write this with one symbol. It's called a plus or minus symbol. Oops, sorry. So the plus or minus value of 2. So the square root of 4 is plus or minus 2. Now this is going to be extremely important because when we use square roots to solve quadratics, we're going to need 2 solutions. So it's important that we get both the positive and the negative root out of the square root. So now if we look at a couple of examples here, and this is just a couple examples to show you when you might want to use factoring and when you might want to use square roots. Let's take a look at the difference between a couple problems. We can see here, I'm going to use the same exact problem. Now in this first problem I'm going to use zeros as my method of finding it, and on this next one I'm going to use the roots. And so you can see that this is a difference of squares problem, x plus 2, x minus 2, and they both equal to 0. Since that's the case, I can find what those x's values are to equal 0, and we find the 2 values that show us what x is when function is equal to 0. Now, that's the zeros method where we find the actual solutions using the zero product property. We can use roots, however, by moving the 4 to the right side, and this gets the x squared, or the squared term, isolated. And so the way we're going to use roots or square roots is we're going to actually take the square root of both sides, and if you just recall, the root cancels out the power, leaving us x, and we saw the square root of 4 is plus or minus 2. Now you can see that we have a positive version and a negative version, just like when we found the zeros. So this is going to give us basically the same answer. So this is a good example of showing you how it can work to get the roots and the zeros at the same time. So let's take a look at some examples on the notes and how we would do this. Look at example number 1. If we look at 2x squared plus 1 equals 17, we could choose to move that 17 over and get 2x squared minus 16, and then I could factor out a 2. But you can see here that this is simply not going to lead us anywhere. We cannot factor x squared minus 8, and so we really have no way of coming up with the x values through factoring. So factoring won't work in this case, and so that is just going to be a method that we can't use here. So what we're going to choose to do, however, is to isolate the squared term. And if we isolate the squared term, we can then use our square roots to help us solve for the x values. And so you can see here that we isolate the x in much the same way, or the x squared term the same way that we would isolate x. Once we have the x squared term, we can just simply take the square root of both sides and simplify the radical, and that would give us our final answer. So what I'd like you to do at this point is take this example problem and use it as a guide, and to work sample problem number 1, part A and B. Okay, let's take a look at these problems here. So the first thing I want to do is I want to take this and I want to get that x squared term isolated. Now that I have x squared isolated, I can simply take the square root of both sides, and that gives me x equals plus or minus the square root of 12 over 5. Now, if you recall from simplifying radicals, we cannot have a radical, a fraction underneath the radical, so I can simply break that apart. And then we run into another simplifying radical rule that says we can't have a radical in the denominator, and so hopefully you remember how to rationalize the denominator, and that's going to give us x equals plus or minus the square root of 60 over 5. Lastly, we have to simplify the square root of 60, which is going to give us plus or minus 2 times the square root of 15 over 5. And that will actually cover both of our solutions because we have the plus or minus sign with the answer. So that gives us a positive and negative version, which gives us 2 solutions, which satisfies our degree. Alright, now let's look at part B. Part B looks a little bit more straightforward. Again, we're just trying to isolate the x squared term first. Then once the x squared term is isolated, I can use the square root of both sides. Make sure that anytime you square root both sides, you need a plus or minus with the radical. And then that gives me x equals plus or minus 2 times the square root of 5. Alright, in the next video we'll take a look at some square root problems that give us a variance in the types of answers that we're going to get.